Google's new model Gemini 2.5 Pro might have just completely killed RAG as we know it. And I got the data to back it up. So for context here, make myself a little bit bigger. Gemini 2.5 Pro currently has a million token context window, but it will be going up to 2 million in the near future. For reference, that's about 30 Great Gatsby's, which is about 60K tokens each. So that's what we get to work with here. Imagine 30 Great Gatsby's you just throw into the context window. And so typically speaking, here's how RAG is generally done. And we have another video on this if you want to check it out. But you have a bunch of data. Could be, internal documents about your company. Could be some other data you're retrieving from like maybe financial reports that come out annually or quarterly to supplement the model's knowledge, which doesn't continue to update. You have some amount of data and you will chunk that. So you make it into smaller chunks and those chunks get turned into embeddings. The reason you make it into smaller chunks is obviously you need something small enough that the model can then eventually pull from the vector database. So that gets created in embeddings, and those are stored in a specialized database called the vector database. When the user asks a question, that's created, transformed into an embedding, sent to the database compared with the embeddings there, and then the model, or excuse me, the database spits out some chunks that are relevant based on this kind of usually like semantic similarity between the two embeddings, and then that gets provided as additional context with the user query. So if the user was asking, hey, how did Starbucks do on their last quarterly report? That would be information that the model did not have, since the models are kind of frozen once they are launched in terms of their knowledge. You would be kind of doing that flow here and we get some chunks about the quarterly results from Starbucks. And so that's a kind of example I've laid out recently where you basically throw in a bunch of, you have a bunch of data, a bunch of 10Ks that you'd be eventually storing in your vector database and kind of shooting this way. And so RAG is really helpful in that situation because this data is constantly being updated. But there's a new approach called CAG, which stands for cache augment. And generally, to really boil it down, you get rid of everything else and you just send all the data and then the user query. And you can kind of get smart about this. So in our finance situation, if we want to allow our users to not only ask about Starbucks, but maybe about Walmart or other publicly traded companies, we can do some like meta filtering such that we're not sending Walmart data when the user is asking about Starbucks. And then, that's kind of like a hybrid here. But generally, we're throwing a bunch of data just in the context window rather than doing this kind of chunking and embedding and all this other stuff that's very complicated and can lead to better results sometimes, but it is a lot of setup. And generally speaking, the knock against this type of approach in the past was a few things. Well, just think about like when GPT 3.5 came, the context window was only 4,000 tokens. So it just wouldn't have been possible then. And so the knocks against this type of approach is it's expensive, costly, and slow. And so, crude over time, but LM cost going down way over time. Context windows going way up over time. And we also have the models are getting faster as well. And so we could see that a little bit more here where we have costs. This is kind of just a snapshot of like the most recent 5 models from a couple of the providers. You can see we're getting way low, of course, with O1 Pro being a couple of outliers here. And you see a lot of Google models in the bottom right quadrant here. And this is only going just from March, so it's not like fully eclipsing it. And we also have context windows going way up. Generally pretty easy to grok. And so that kind of throws the window out of expensive and costly. And then in terms of slow, models are getting faster, but you can also do things where you are leveraging prompt caching to some capacity. So if you have just a bunch of knowledge that the LM should have, and it's not changing too much, then you can just cache that in the like initial request. And so then the model doesn't need to kind of hash that every single time it's getting a request. And so it becomes really, really fast while having all the knowledge necessary. And so a couple of like relatively recent research papers that I think were worth looking at. And we're going to do a deeper dive in our blog at some point about this, but this one here, don't do RAG, blah, 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 is all you need. So we'll look at the results. So small, medium, and large is context size. They only got up to like, I think a couple, either like 100,000 in tokens for large, which is kind of small in comparison to what Google can handle in its context window, but generally their approach wins out against these couple different RAG methodologies, except for here, I guess, in one. Either wins or it's very close in that one case. And then, of course, it's going to be looking at retrieval time and generation time is also much faster because it's cached. So it's not reprocessing all those 100,000 tokens every time. Another one, this was a really fun one from Databricks, I think in August, but basically similar type of thing. Took a bunch of models, large context window length testing of RAG versus, I called it just long context, LC. And you could see the performance here. So generally speaking, as we were sending more context, the models got better. There's a little bit of like a reversion here. It's hard to tell without like an additional data point. These models up here, which is like I think a couple OpenAI models, but you could see they were able to test up to the 2 million context window with the Gemini models 1.5 Pro and Flash, and it's pretty consistent, which is like surprising to me. And it's the first I've seen data that really shows consistent performance at these really, really high levels. Of course, you can see some models like the open source models is generally the ones that decrease. And so, the takeaway here is that the closed proprietary models are better at handling large context. And here you see very similar kind of plateauing. You do see some jumps down at the top for some of these proprietary OpenAI models. The Anthropic ones stay stable, and then the Google ones stay stable, even though at a lower level of accurateness. Other cases, which was interesting that they went into, so for Gemini 1.5 Pro, the main failure case we'd see two, gray and blue. I don't know the difference between task failed and wrong answer. I'd have to look back at that. I know a lot of it was for refusing or like content security policies or content policies, which we see with the purple, big purple here. That's something that got triggered a lot in a couple of these situations. Let's see what it said. Yeah, I know for the Google one, it was a big, like, for some reason, I guess, the more stuff you have in there, the more, like, bigger chance you trigger one of those flags. And then one other one here, it's a pretty simple test, really similar stuff. A couple, they like popular data sets, long contents versus RAG. They do something called self-route, which isn't super relevant here. Not the newest models. See, not only are we seeing faster, we're seeing better performance, right? We can see how much higher these are, and that's because there's so many things that can go wrong when doing RAG, from how you chunk the data, how you retrieve the data. Like there's just multiple steps here, how you even include that with the final request. There's so many things that can go wrong, and so you're increasing your surface area of potential errors just every step there, versus when you're just throwing the context window, it's one step. It's much more simple. And if those that are still saying stuff about it being expensive and things along those lines, I would point that the opportunity cost of setting something up, a developer's time, is way more than, a couple bucks here or there. And so I've always been a little bearish on RAG, but there are a couple situations where I think it makes a lot of sense. In this financial app that we were talking about before, where you're constantly updating the data, in that case, it might make sense to have like a store for that. I think there are other ways around it, such that you don't need to have a whole like different type of database and like chunking and retrieval. In terms of like metadata filtering, there are some things that you could do there. If you're constantly updating it and it's really big pieces of data, like 10Ks or like 100,000 tokens, so it's like quite large, you could of course filter that before, but that would be like an example where it might make sense. So, sometimes clients have needs in terms of like segmenting the data that is in your application that's kind of higher level, but that might make sense as well. But generally, I like to opt for simple solutions as a starting point, and this works. We're running some needle in a haystack experiments with Gemini 2.5 Pro, which we'll release soon, and I've just been really impressed, to say the least. And so that's all we got. Just checking something there. And so let me know what you think. I think this is a really cool approach and thing to start to think about with caching and just kind of, essentially vibe prompting the whole way by just giving the model everything, having a request, and having it figure it out. I think especially the thinking models are very good at this stuff. And so let me know what you think, and we'll talk soon. See ya.